So the story for tonight is going to start with the beginning of broadcasting, 1920, 1921, and the KDKA and the first commercial broadcasters coming on, and that got to where the some of these first factory-made sets for the radio fans to hear these broadcasts are the regenerative sets, and these were some of the first sets that got my interest as a collector. And but for their day, they were just really difficult for the average person to operate. And soon the Neutrodynes came out and other TRF3 dialers starting in 23 or so. And now radio owners could at least keep a log of their station so that anyone could now operate a radio just by setting the three dials and making sure their tubes are lit up and their battery is good. And as the radio tubes were expensive, the early four tube design that was used in the Neutrodynes utilized reflexing in one stage. So uh, it got something close to the performance of a five tube set, but still very low output. And there was really no need for volume control. As listeners were prepared to spend some more money, the five tube Neutrodynes came on the market. And like in the NR5 here in the diagram, let me see if I could turn the little laser pointer on. Instead of having a volume control, they have the three choices for plugging in your speaker or headset at three different levels, just the detector and then each of the two audio stages. And then the horn and cone speakers of the time didn't offer much efficiency or fidelity, so radio engineers still saw no need for a volume control. Just go for all the gain you could get. And these were still the radios and speakers that I was happy to collect and get working. Then companies began producing radios, although in smaller quantities, for the really serious radio fan, which would get more gain by cascading more and more triodes. You could see the picture there of the 10 tube Navy model from Norden Hauk. And as the diagram shows of the 10 tube model, the Lutz, Norden Hauk, and Scott were among the companies producing these really high-end sets for their high-end customers. And then for me, there was a big event in the world of radio collecting. This is Dr. Muchow in his museum in Elgin. And sadly, he passed away, and the family put up the collection for what was going to be the biggest radio-related auction to that point. So in New Jersey, I cleared out my minivan and pointed it west, and I was ready for the auction. This is the picture that was in Antique Radio Classified of the anxious crowd waiting to enter the big room. That's me with my Yankee hat down the bottom there, and some of you would recognize Ernie Height and Ed Bell over there too. So Rich Estes, the auctioneer, starts the proceedings, and we're all ready to bid. Ed Bell had put his markings down in chairs for us. So he always wants that row right behind the family. So I noticed a trend as the auction was getting moving. There were tables full of really small things, and there was an area in the back with really big things, and they would alternate bringing things up for auction from one or another of these places. And I noticed that the high things were selling for lower prices, and the smaller things were selling for higher prices. They got a heck of a lot of money for open filament tubes too. I don't know why they were going crazy about that. But I noticed that small things, smiley auctioneer, big things, frowning auctioneers. This made sense to me all of a sudden because people flew to Elgin to go to the auction and would either be packing things to go back, or they might have gotten there with smaller cars, and they couldn't fit many of the big things. So here I was with my empty minivan. I set my sights on this Lutz 7 Seas console model on the right there, and I managed to have the winning bid at a what I thought was a pretty low price. So here it is set up at my house using a short wire antenna, and I was anxious to try it out with a distant station and take a seat and enjoy the music. Then in a few minutes, the atmospherics must have changed, or the skip came in or something, but it went to a really strong local station. And wow, the force is so strong, I couldn't pull myself out of my seat. The dogs were howling in pain. My hair was being pulled out. You could see big chunks missing down there at the bottom. And my scalp has really never recovered from this event. But how could this happen? I've listened to all kinds of radios. This never happened to me before. I had, it was just a totally new experience. I've had cathedral sets, tabletops. What was going on here? So I started to do a little research. I was committed to finding out how this could happen. So I searched out and found literature that tells me about the Lutz 7Cs model. Screen grid tubes, dynamic speaker, and number 250 tubes. I had to find out more about this. So here are all the benefits that were being claimed about this new vacuum tube. And how did it do all of this stuff? It had improved fidelity, no greater cost, decreased hum, less interference, shorter antenna, greater distance, a miracle. Well, it's the screen grids that make the difference, as it changes the interelectrode capacitance and allows engineers to get greater gain from each tube in the set. And this chart that was published in, I believe it was Radio News, shows the difference between a screen grid receiver with 5 tubes and a triode receiver with 6 tubes, and it's later number 27 tubes. So 34 per stage with that 5-tube set, and you get a total amplification of 2.35 million. And on the triode set, 575,000. So also, this chart shows that the output tubes were being dramatically improved in the 1920s from the lowly O1A with listed as a 0.05 watt output to when you got to the later battery set 71 tube 71A with 0.79 watts. But then they were developing, like was in the Lutz, this killer number 52 with 4.6 watts. And research by Chester Rice and Edward Kellogg at GE led to the development of a new kind of speaker known as a moving coil speaker or dynamic speaker. And it was first introduced on the market in the as a Radiola 4, which was an add-on piece you would buy to go with your radio. And it included a 6-inch paper cone with a coil wound on the cylinder attached to the apex of the cone. The outer rim of the cone is attached to the metal frame by a flexible ring, and it is mounted so that the coil is in the air gap for an electromagnet. And power for the electromagnet is supplied by another power supply separate from the radio in the Radiola 4. And in later sets and in some new console radios, the electromagnet coil was part of the power supply. So other companies like Magnavox produce these new dynamic speakers as upgrades for radio fans, and also produce them for companies to include in their new console radios. And you can see now with this increased efficiency, they were proud to call them loudspeakers. So these new powerful radios were now being promoted to radio listeners. And this comparison shows how much less antenna was required for the same radio performance over a 3-year period. And the range had also improved tenfold. So this Norden Hauck set has 5 screen grid tubes. So you can imagine how much difference between tuning in 2 different stations you're going to have. This will blow the roof off. So engineers had a new problem to deal with in radio design. They called fading and blasting, even blasting and fading over and over again. And this would be really a problem for the radio listener. So, who will come to the rescue of the unsuspecting radio owner to save him from this vexing problem? Is it a bird? Is it a plane? No, it's this guy. This guy. This is little Harold Alden Wheeler at his ham radio station in the early 1920s. Uh, he was more than a hobbyist, though. Wheeler is an experimenter and has produced some of his own inventions. And his father, who knew Lewis Allen Hazeltine from work in the on the radio commission in Washington, introduced Harold to Hazeltine. And at the time, Hazeltine had his patent for his Neutrodyne circuit in application, and young Wheeler is telling him of his plans to solve this triode problem in a similar fashion. So Hazeltine decides to offer Wheeler a percentage of the royalties that he would get on the Neutrodyne over the years and to join his team. So better to join forces than to do battle. So Hazeltine forms the Hazeltine Corporation, and Wheeler starts as a summer job in the Navy building at Stevens Tech in Hoboken, and in the winter he's back at school in Baltimore. So Hazeltine Corporation had rented offices on the top floor of that building, and Hazeltine would only have to go from teaching classes downstairs up to his offices on the top floor of the Navy building. The just a little side note: the Navy building isn't there anymore, and the IEEE designated the spot for one of their IEEE milestones. And I was fortunate to attend and act as the historian in the presentation of the milestone award at Stevens. And I got to meet Hazeltine's grandson and Hazeltine's son, Professor Hazeltine at Brown. And he's in his 90s, but still a pretty sharp guy. His hearing's a little rough, so it was hard to keep a conversation. But I had brought some of the Neutrodyne artifacts in the Navy receiver that Hazeltine designed, and he was thrilled to see those old things that he hadn't seen in many a year. But anyway, that's Hazeltine teaching class down here, and you could see the guy with his slide rule getting it all loosened up for the season. So during his summer job, Wheeler comes up to Hoboken, and he's working at Hazeltine, and he gets to get caught up on other developments that are going on in the radio industry. And he goes back for his to school and starts working on some ideas for an automatic volume control for these radios that are having all this fading and blasting. And when he was back in graduate school and at home in Washington, D.C., over his Christmas break, he builds a prototype of a superhet radio with diode AVC. And he has witnesses come and attest to its performance during that Christmas break. And back in Hoboken at the Hazeltine Corporation, where they're working on all kinds of improvements for their license holders, they also get to work putting together patent applications for Wheeler's AVC circuit. And they want to cover all the bases. So from practical experience in lawsuits over the Neutrodyne and other things, they come up with 10 different applications covering every possible form of automatic volume control that they could think of. But this is the basic circuit for diode AVC. Wheeler explained later years that others were looking for complicated solutions to the problem, and he found success by looking for a simple solution. So this is what he came up with. The a triode at point A there is configured to be a diode. You can see that the grid and plate are shorted together. And at point B, they get a AVC develops an AVC voltage level, and it is sent back to the grid of the first RF amplifier to control the gain. At point C, now a steady signal can be varied by a volume control, which is now part of the circuit, and the radio would produce a more comfortable and steady output. So this graph shows the results of applying AVC to either 1, 2, or 3 RF stages, and how without control it just goes up to max out the amplifier, and as the RF antenna voltage is changed with 1, 2, or 3 stages regulated, it stays at a comfortable level. So meanwhile, back in the radio biz, more improvements are happening to radios in the late 1920s. Radios were now included the introduction of AC operated tubes, ending the need for batteries and battery eliminators. So what was a company like the Philadelphia Storage Battery Company going to do? General Manager James Skinner borrowed funds to begin converting Philco into a radio manufacturing company. So Philco already has an established line of dealers. A lot of them were car dealers that also sold the radio batteries and the battery eliminators from Philco. And to get a fast start in production, Philco buys the Timmins Speaker Company and the William Murdoch Company, which was already a Hazeltine license holder. So they also decided to use Hazeltine Labs engineering services to design the radios, and that project was headed by Harold Wheeler. So that was the lineup before, when they had all types of battery eliminators and batteries, to the very first metal sets that Philco produced. And the first ones were called the Neutrodyne Plus. They were good performers, but their ultimate plan was to get a screen grid tube set on the market with AVC, and that was planned for the 1929 model year. Now, a time delay caused by the delay in getting a patent granted would have really put things way out of line. If you look, some of those applications went in 1927 and weren't really issued until 1932. So here it was 1929. So they just had to have faith that they stacked all their patents, that nobody could break it. So all they could do is go with patents pending. And in late 1929, the Model 95, the new Screen Grid Plus, was available for Christmas sales. And on the back, that's what you see, that a list of, they also had to have their RCA patents license at Philco, and all the other patents for AVC were still listed as patents pending. And this is one of the versions of the Philco Model 95. You had choices in simple cabinets or complicated cabinets, and this one's a real nice one. It's at the Info Age Museum. We'll get into in a little bit. That's the rear view, showing 3 screen grid tubes and the dynamic speaker mounted up top. So it's the 9-tube chassis, as the 3 screen grid tubes, push-pull audio output tubes, and it's proclaiming the best performance on the market. At the time, famous symphony orchestra conductor Leopold Stokowski had been refusing to listen to radio, perform on radio, because he said the sound was so bad. And now, with the great introduction from Philco, he now sees radio as being perfected, so he's going to allow broadcasts of the Philadelphia Orchestra. That or Philco had a good budget for advertising, but one way or the other, they were now sponsoring a radio program with Stokowski. So this is that Wheeler prototype, the 1926 Washington receiver is what it's called, and it's on display at the Radio Television Museum at InfoAge in Wall Township, New Jersey. This is it out of the display case. Some items to note where the arrow A points. You can see that the construction he used to make this prototype was actually pieces like from an erector set, the little brackets and angle pieces to mount the condensers. And at B, we can see the a meter. And what he had done to monitor the performance of AVC was he put a small milliamp meter in series with the B plus going to the RF stage, so that when the bias from AVC would control it, you could see that the current being used by the tube would drop. And in C, you can see the modular design, all these clips and a little bus of wire, so that if he wanted to make changes, all he had to do was disconnect the module, make his changes, and put it back in and measure the performance. So these on the left are the RF and oscillator modules. And he chose a superhet design because for the AVC to work, you had to have a pretty strong input signal. You couldn't just go and add diode AVC to say an older Neutrodyne or something. So it was a superhet with and to because he was using triouts, he did neutralizing it for the RF stages, so that you could see the inner winding on the coil. And then these modules are the AVC detector and the audio detector, which were two separate things in this design, and the volume control and the output tube. So although it would have been nice to make the prototype work again and measure the AVC response, it was decided that this is a historical artifact, and the decision was made not to tamper with it. But we did have an alternate plan. The museum has the working Philco 95 on display, and we received permission to measure its performance. So this is part of the lab at the Radio Television Museum at InfoAge. And the Philco was hooked up to their test equipment. And we were able to get some test points to actually monitor the signal input level and the AVC voltage. So this graph was compiled. You can see that as the signal level changes, the AVC level climbs, or the climbs by being less negative. And it's this curve in here that where we're making the change, so it's not a straight line. You'll see in the next curve. Here's another of the signal level versus the audio output. So again, we're getting a curve. And when we combine all the information into this graph, you can see that without AVC, it goes to maxing out the audio stages. And for the same input, you can see with AVC that the audio output is diminished. So you get this kind of an area that gives you the performance you want. My conclusion as a biased listener was that it's a lot better than no AVC. And one of the problems with putting AVC on a set at that time was the number 24 screen grid tube that was being used as a cutoff that's that's not one suitable. It was when later remote cutoff tubes came out that the AVC could really do the job that you wanted. So this is Harold Wheeler with the Washington receiver, photographed in April of 1976 for Electronic Design magazine. And this is the set over the years. That's very early on and after 1926 on the top picture, as it sat in Wheeler's office for years at Hazeltine Corporation. And then on the bottom is as it sits now in the museum. So during the 1930s, the Hazeltine Corporation had been defending patent infringers in several cases, including RCA and Detrola, and they had been winning every case. But as more time went on, in 1942, the Supreme Court turned the patent situation upside down, ruling that AVC is not a new invention, but just a reconfiguration of existing technology. And by then, to keep going on with any work in legally, they just the Hazeltine Corporation let it drop. But Harold Wheeler later in life took a philosophical view to the patent being declared invalid because he recognized that the income from license holders during that time period is what kept the company solvent during the Depression years. And it wouldn't be until work for the military in World War II that things would pick up for the Hazeltine Corporation. So in that interview for the Electronic Design magazine, Wheeler was asked what qualities must a creative engineer possess. And he replied that he must be wired the right way. You can't attribute his creative ability to education. He's got to have an inquiring mind, deductive reasoning, and abstract reasoning. And after doing this research, I can just say that it now appears to me that Harold Wheeler was one of those guys who was wired the right way. So thanks for watching. This is my assistant Lila to the left, and I'm practicing the art of manual volume control during the blasting and fading of the Lutz 7Cs console. Thank you.